This video is to get us started into lesson 6.4, which is called rational exponents. So what we're going to basically be looking at is taking all the things that we were doing with cube roots, square roots, fourth roots, and all the different product rule, the quotient rule, the rationalizing, all that different kinds of stuff. We're going to look at that now all from looking at the radicals and from a different perspective. And that different perspective is called rational exponents. All right, very simply, we have a property that says if you're taking the nth root of something, another way to write that is x or something to the 1 over n power. In other words, the key here is index becomes the denominator of the power. The index of a root is the same as writing an exponent with the index as the denominator of the exponent. Okay? So some examples, some simple examples here. Another way to write the square root of 36 is 36 to the 1/2 power. Why 1/2 power? Because the index on 36 is 2. The third root of 64, another way to write that is 64 to the 1/3 power. Again, the index becomes the denominator. The fourth root of 16 is another way to write 16 to the 1/4 power. Okay, so the first thing is, let's try to see if we can convert these, all right, or look to simplify these. Now the problem says take 216 to the 1/3 power. Well, I'm going to look at it as the third root of 216. Now I know that the third root of 216 is something that I can do. And the reason why I can do it is because I know this is really the third root, and another way to write 216 is 6 cubed. So the simplified form of 216 to the 1/3 is simply 6. How about the next one? Excuse me. 7 to the 1/2 means the square root of 7. If I take the square root of 7 times the square root of 7, I get the square root of 49, which is 7. All right. How about C here? It says 5 to the 1/4 times 125 to the 1/4. I'm going to look at this as the fourth root of 5 times the fourth root of 125. And I know that this is really saying the fourth root of 625, which is really the fourth root of 5 to the 4th, which simplifies to 5. Now, this is one way of doing these. There are more ways that we're going to be talking about over the next couple of days. All right, but this is one way where I can rely back on that skill that I took last week to develop of simplifying radicals. Now, the second thing that we're going to focus on here is applying what's called the rational exponent rule. And we've already learned that a to the 1 over n and the nth root of a mean the same thing. The nth root of a is a to the 1 over n. A to the 1 over n is the nth root of a. But what happens if now all of a sudden we bring in a power? Well, that power could be inside or that power could be outside. Either way, we're going to take and be able to rewrite this as a to the m over n power. Notice that the m, the power of the expression, is the numerator. Notice that the n, the index, is the denominator. Okay? All right. The other thing that we got to take a look at here, it says if m is negative, then a cannot equal 0. All right? We're going to see why. If you know your rules for exponents, the next thing that we're going to talk about when it comes to a negative value in a power, or what that means is actually we're going to move it. Okay? All right, so let's take a look at each one of these. They want me to change it from exponential form. Exponential forms means that we have exponents. Okay? So the first exponential form says x to the 3 over 7 power. I know that this is implying that we have a 7th root. Why? The denominator is 7 in that fractional power. okay? I know that x is the radicand, and now I have an option. I can either put that 3 inside, which is how I would do this one, or I could rewrite this as the 7th root of x and take the entire quantity and cube it. Either one of these answers is technically correct. And the reason why they're correct is because of this rational exponent property. Okay? Now, which one do I always want you to do? I can't tell you that. It totally depends on the situation and the scenario. More times than not, I would answer it this way, the 7th root of x to the 3rd. Let's take a look at the next example here. The next example says y to the negative 3.5 power. Now, first off, I see two things that are unique here. We haven't looked at a decimal power, and we haven't really talked much about negative exponents, all right? But that's okay. I don't want to deal with a decimal. So I'm going to rewrite this as y to the negative 7/2 power, all right? I want to do that so that I can apply this property again right here called the rational exponent property, all right? So the first thing that I notice here is I'm going to be dealing with a square root. But the second thing I notice is, what does this negative mean? That negative simply means take it and move it from a numerator, take the entire quantity and move it from a numerator to a denominator. So this is really 1 over y to the 7/2 power. All right? That's all that a negative exponent means. You should know that from Algebra 1, but if not, you may want to do a little research since we got time today on what a negative exponent is. Okay, you got the internet, you can do that. Now, I still need to convert this, so I'm going to rewrite this as 1 over the denominator of 2 means square root of y to the 7th. And again, I could rewrite it as 1 over the square root of y to the 7th. I can either put that exponent of 7 inside or outside. It totally doesn't matter. All right? Now, we would then go further with this, but all that they asked us to do here was convert it. They didn't ask us to also simplify it. Okay? Let's take a look at these next two. It says, what are the square root of a to the 5th and the 5th root of b to the 3rd written in exponential form? So if you kind of have figured it out by now, guys, my number one concern with you guys today is, can you convert between these two forms, and can you simplify some basic square roots, third roots, fourth roots, stuff like that? Okay, so this first one here, I know that the index is 2, which tells me I can write this as a to the 5/2. I'm done. I notice on the second one, the index is 5, so I can write this as b to the 3/5 power. Once again, notice the index became the denominator of the exponent. All right? We were given in this problem what's called radical form. We simplified it to exponential form. Now, we're going to do one more problem here. This is just an interesting problem, I think. Applying Kepler's third law of orbital motion, it shows you how you can approximate the period in Earth years it takes a planet to complete one orbit of the sun. All right, it is defined as the function p equals d to the 3/2 power. So what you're going to start to see in science classes is sometimes they're not going to use the radicals, the square roots, the third roots, the fourth roots. Instead, what they'll do is they'll give it to you in a fractional exponent form. All right, and it says where d is the distance of the planet to the sun in astronomical units, AUs, which is about 93 million miles, or the distance that the Earth is from the sun. Now, for this specific scenario, we know that Mars is 1.52 astronomical units away from the sun. They want to figure out how many years does it take for Mars to orbit the sun one time. How many Earth years does it take? So to figure this problem out, it's actually pretty straightforward and simple. P is my period, which is going to tell me how many Earth years it takes, if you will. D is going to be 1.52, and I'm going to raise that to the 3/2 power. Now, I'm going to change this to the square root of 1.52. I'm going to figure that answer out and then cube it. And that will tell me the period in astronomical units that Mars takes to get around. So let me pop up my calculator here. I take 1.52, take its square root, and then I take that answer and I raise it to the 3rd power. And that tells me it's approximately 1.87 AUs. Now, from that AU, we could convert it into miles. We could convert it into how many years, months, weeks, days, whatever they want to do. But this is all we're going to do. All right? So where we're going to go from here, you may want to start to explore this. Maybe even if you've got time in class, do some internet research on this. We're going to start to look at the properties of rational exponents and then take a look at some of these that we're going to be getting into. All right? These are not difficult. They're just different. All right? Hopefully this helps. Hope you guys had a great day.